Well, good afternoon, everyone. This is Michael O'Malley here with the severe weather outlook and discussion for November 24th, 2020, recorded around 2:20 p.m. Eastern Time. Taking a look here at the severe weather pattern today, November 24th, we have a slight risk for severe weather, mainly situated across parts of Oklahoma and the far eastern Texas panhandle. And what's been happening today is we have lee cyclogenesis occurring with a area of low pressure coming off the lee side of the Colorado Rockies. This will be moving generally towards the north over the next several days and kind of northeast. This will be moving kind of east northeast and generating a frontal boundary that is, going to be moving east along with it before washing out later in the week down here across the southeastern United States. Now, if we look here at the zoomed in look here, this is coming from the Storm Prediction Center Mesoscale Analysis page. Here you can find it just by going to SPC Meso Analysis or Mesoscale Analysis. So you can see what we have today is an area of slight risk. This is generally propagated from right around central Oklahoma back in through the Oklahoma-Texas Panhandle, then back in through portions of far eastern Texas, and then all the way up into extreme southern Kansas. And the reason for that, you can actually tell that we have an area of low pressure. If you look here at the wind column, we have generally south winds here around central Oklahoma today. And then we have this turning that is ever so present. You can definitely see that cyclonic curvature. There's an area of weak low pressure right here in the Oklahoma-Texas panhandle moving towards the north and east like this. So we have an area of low pressure. We have southerly flow. We talked about this yesterday. So we're getting a lot of moisture now beginning to be evected. You can see these isobars here. Notice that all these isobars are basically aligned out of the south here, out of the south going towards the north. So this is bringing up a lot of Gulf air down here. And we can visualize this by going to the the observed soundings and also the station plots. This is all of the station plots from the ASOS, stations, basically comprised from weather service offices and airports, etc. So you can clearly tell that there's an area of low pressure, and you can see up here at Dodge City, we have a wind coming generally out of the north, and then here, right around, Oklahoma City, we have a wind coming out of the south. Now you can see that the temperatures are not very high right now. The temperatures are only in the 50s across portions of eastern Oklahoma. Now we can see down here, just sitting south of here, we have temperatures in the 70s and even some upper 70s located over here towards Dallas, and even further west than that. And we can also see that temperatures are generally in the 60s and high 60s across northern Louisiana. So this would point that we have a warm front that is roughly somewhere in about this vicinity is where I would draw this warm front to be. It kind of washes out the further east you go, but you definitely have some warm frontal gradient right here, and you can actually see temperatures in southern Oklahoma are getting up there into the 60s, but in northern Oklahoma we have temperatures struggling to get out even some of the lower 50s. So this is definitely not a very high severe weather threat at the moment. But what you'll start to notice here, if we back this up 4 hours ago, where we were, I don't think those station plots actually go back that far, so that's tough. But what you would have seen a couple of hours ago is these temperatures down here have been warming quite substantially. This warm front is getting infected by all of this flow coming like that. So you have all of this flow that's trying to push up towards the north. You have southerly flow, but you have generally, you generally have a southerly flow, but generally pulling all of these winds towards the north. So you'll be getting this warm front to sag northward as we go throughout the rest of today. Now, this warm front has been a little bit slower than expected, but it has generally been progressing northward. Now, you can actually look at this another way too. This is the effective bulk shear across the region. And what we're really looking for is, you notice how the weak numbers are out here across eastern Oklahoma. The strongest numbers are closest in through where the pressure falls and the surface low is. Now, you can see that these values are in the upper 50s across portions of southern Oklahoma and far eastern Texas. And you can see the forecast here from the Storm Prediction Center expects these numbers to not only increase but surge northward throughout the day. And this is very consistent with what we've seen from this warm front trying to lift northward, that these values will be surging northward. And you can actually see here by 2 hours from now, a lot of these weaker values will start to be overrun by a lot of this stronger advection out here. And this warm front's lifting northward, and it's going to allow a lot stronger instability in shear across this area, especially maximized across the warm front, which seems to be positioned something in about here right now. So as this warm front is gearing up to move northward and has been throughout the day, along this warm front is where you could see your maximized tornado potential. So you could see something along the lines of right over here, or maybe back even in here, could be your maximized tornado threat. And the Storm Prediction Center is definitely agreeing with that. If we actually go back and look here, the highest tornado percentages are actually right in this region. Very small corridor, but that's because as the warm front lifts northward and we get the strongest daytime heating and the surface low that is positioned right here to draw up a lot of this moisture and shear vectors, we are definitely going to have to watch there for a few isolated supercells even to develop. Now, if we look here at the storm relative helicity values, this is just kind of what we're looking at here is kind of the overall effective shear across the region. So this is storm relative helicity here, or, effective storm relative helicity. But you do have values approaching 300 in the, effective layer. Definitely more than supportive of supercells, especially right along this region here in central and northern Oklahoma. And you can see back here where the low, again, the low was kind of initialized back here. So a lot of what we have is shear that is going to increase over the next several hours. And this is looking here at the effective inflow layer as well. And all of this kind of shaded red color right here, this means we've got elevated storms out here across the open warm sectors. So what you'll notice is that your strongest area where your greater potential is for tornadoes going to be right in this general vicinity, right in through here. Because once you start getting over here, now you start to get into where we're getting elevated storms instead of surface-based storms. And you can see that we'll be getting a break in that as the dynamical support increases with the approach of this, cold front and the approach of the area of low pressure. So we're going to see a lot more of this moisture be lifted in. And if we look here at the surface-based CAPE values, we notice how out here across eastern Oklahoma, there is absolutely no surface-based instability. So everything across here is all elevated storms. All of this up towards the north across Kansas and northern Oklahoma, this is elevated storms right now, and actually may put a slight damper on the severe weather potential later tonight across that region. Now, if we look here at what's going on really across portions of eastern Texas and western Oklahoma, we have surface-based instability values, surface-based CAPE values over 1,000. And if we compare that to the mixed layer CAPE, which is basically above the surface, if you took a surface parcel and rose it upwards, what is your mid-level CAPE values going to be? And you can see these are approaching 500 to 1,000. And again, as this warm front begins to approach here, these values are going to dramatically increase. And we can see that going forward at these values dramatically increase and expand with coverage across the vicinity, even some, over 1,500 CAPE, mid-level CAPE across central Oklahoma later today. This is definitely going to be supportive of a fairly decent severe weather event across the general vicinity. Now, one way we can kind of analyze the situation is looking at the skew T log P diagrams. And this is one example. This is the 18Z radiosonde from AMA. This came from portions of eastern Texas, really central and eastern Texas here. And what this really shows us, again, this is kind of in that area. Again, if we kind of go back here, this is within that general area of relatively higher moisture content, relatively higher vectors of shear and instability. And if we look here, we have a surface dew point of 46, so not terrible, but certainly not supportive of surface-based storms. And again, this is all north of the warm front right now. So the warm front has not reached these areas. And then the AMA sounding here was also 63 surface temperature. Now you notice what we have here is we do have a tad bit of a inversion right here. This is the cap right here in the atmosphere. We'll highlight that in a better color. This right here is the capping inversion right there, because you can see the temperature sharply increase with height here and then decrease once again. So there is a little bit of a cap here in place. Now, it's not a very strong cap. You can see in the mixed layer, SIN values are only about 25, or minus 25. So that definitely indicates that it's not a very strong cap here. And what you'll notice is that there's not a very deep layer of elevated mixing here. There's not this, supreme drop off, this super big drop off like that, and kind of running up all the way out here. But what you'll notice here is actually from the sounding, the temperature once again increases with height here at roughly about 300, roughly at about 300 millibars. So we're looking, closer towards, about 20,000, 25,000 feet at this moment that we're looking. So the temperature is rapidly now increasing with height. This basically tells us that the supercell parameters are likely not going to be one that is relatively supportive. The parameters are just not supportive for severe storms. Now, if we compare this to the 12Z OU, the 12Z Oklahoma City sounding, or Norman sounding, this is the OUN 12Z sounding, we have a different scenario here. We actually have a fairly strong temperature inversion down here and a fairly stout cap. I mean, some of this, is, approaching 200, in the capping inversion. But you can see the temperature there was only in the 50s. We have 53 over 51. However, look at where this photograph is. And again, this photograph is incredibly sharp across this region, an incredibly sharp photograph. This definitely indicates that we have a very high tornado potential later this afternoon, especially because a modified sounding, if we kind of just draw what a modified sounding should look like, we should have a decent amount of, a decent fair amount here of moisture later in the afternoon. And then we also should have this temperature kind of also doing something along the lines of this. We just kind of draw it like that. So that's just kind of a very rough estimate of what we should have. So we should have enough surface-based instability in the first, 6 kilometers or so to provide for a fair amount of a severe weather event down the road. And this is something that could certainly happen. If we look here at the Dodge City sounding from 12Z, you'll notice that, again, much of the same scenario. This one is going to be in the cold sector all day, so we're not really going to expect a lot of warming across that region. So that brings us to kind of the final round here, is looking at the model forecast. So we'll look at the models here. This is the 18Z HER, and this is the 0 hour forecast. We'll go for 1 hour from now. This is by 3 p.m. this is by 2 p.m. this afternoon. So, because the 18Z now is 1 o'clock. So what we have here is in the the HRRR, the HER, we have showers and thunderstorms kind of where we thought we would. Again, if we actually go back and look here at the actual radar, we have showers and thunderstorms across northern Oklahoma and southern Kansas. So the HER is doing a pretty decent job depicting that, although it has not widespread, but scattered to isolated showers across the rest of the area, which we do not have. And it also has showers out here, which we don't have at the moment. Okay, that's fine. So we'll go 3 hours from now, 4. So you notice that we get some sort of cell initiation, roughly, this is 1 o'clock, 2 o'clock, 3 o'clock. So we're talking maybe 4 or 5 o'clock in the afternoon. We could see cell initiation out across portions of eastern or western Oklahoma. Now, again, this is all kind of elevated storms right here. So this is kind of taking out whatever, instability we have out here is getting rapidly depleted by all of this convective, contamination. Now, we don't have showers all the way down here, so this is something that the model could be overdoing is the convective parameters for this time. Now, what you'll notice back out west is that we have showers and thunderstorms developing by 4 or 5 this afternoon, and those then congeal into a mesoscale convective complex by later in the evening. This is by 7 p.m., 8 p.m., 9 p.m., and then we go out to 1 a.m. in the morning with just some cold core convection back here. Now, if we actually look here, what we're going to do is we're going to look here at the surface-based instability. And you'll notice now the HRR, the HER, does do a good depiction of where our surface-based instability is going to be right now. This is by 1 p.m. So we'll go out to where we saw it here on the SPC mesoanalysis. And we can see that all of this instability right here, no instability out here, that is definitely a good depiction of what's going on. Now you can see that we start to get a lot of this masking later in the day, and what this really shows us is that we have the convective inhibition values that are rapidly increasing. Now, what you'll also notice is that you'll notice how this tongue of moisture is getting streamed northward, and this instability is rapidly increasing northward. And this is all dealing with that warm air advection and that moisture advection that we were talking about. Now, by later tonight, we can see here by 7 p.m., the greatest axis of instability is really going to be from southern Oklahoma all the way down here across the front into portions really of Texas. And again, we're not really expecting anything big here in Texas. And again, if we go back to the SPC mesoanalysis, there is a marginal risk all the way down here across into portions of eastern Texas and northwestern Louisiana for the possibility of stronger storms later tonight into early tomorrow morning. So that does kind of fit that narrative. Now, the significant tornado parameters, if we look at that real quick, you can see STP values do dramatically increase later today. So there could be a few tornadoes that do occur, especially right along the warm front. And that's kind of what the HER is showing, is that, the warm front is kind of located in this area right here. So your highest STP values are generally going to be right along this warm front right here, and of course south of the warm front as well. So you're definitely going to have a higher tornado potential right along that. And just for what it's worth, the updraft helicity swaths, this is basically a strength of the updraft helicity. You notice that we do get a couple of updraft helicity swaths across portions of central Oklahoma. So we'll see if that does convert into a tornado threat. Again, I'm expecting the greatest tornado threat right now, basically in line with the SPC's forecast across portions of far northwestern Oklahoma later this afternoon. All right, with that being said, I hope you have a great rest of your afternoon. Of course, I am Michael O'Malley. I'll talk to you guys again some more tomorrow.